Education is the key to sustainable development and economic growth of the country. This video highlights an initiative of Government of India about developing virtual labs. It makes two contributions. First, describes the design and development of virtual labs for strength of materials and fluid mechanics. Second, highlights the impact of using interactive interface. India has a large population which requires quality education. Providing personalized learning could be a challenging if there is a lack of teaching resources, manpower and inadequate infrastructure to provide the practical experience. Virtual Lab is a project initiated by MHRD, Government of India, intending to provide simulation-based online laboratories for science and engineering disciplines. The two elemental subjects of civil and mechanical engineering, strength of materials and fluid mechanics, which require sophisticated experimental setups, are visualized to provide online experimental learning through interactive interface. Strength of material involves destructive testing of assessing different materials, whereas fluid mechanic involves non-destructive testing of fluid properties. Both the labs require expensive equipments and well-trained teachers. The lab instructors teach the process of conducting experiments to a group of students. These concerns can be resolved by using virtual labs because they are inexpensive, immune to calibration issues or mishandling of the equipment, and the student can perform experiment at any time of the day. To provide a realistic experience, the virtual lab uses actual data obtained from the conventional lab. Guidelines followed during the development of simulation. Use of free and open source softwares to make the process cost effective for developers and end users. No interdependency on additional softwares to run the simulation. Compatibility with mobile browsers. There are three cycles in development process. Content development includes theory, quiz, self-evaluation and reference related to the experiment. Simulation development, collecting real lab data, tracing of the experimental setup images and then incorporating both in interactive animations. Testing and development, check for errors in grammar, procedure, simulation, browser compatibility, quality, and each lab is deployed through automated deployment service. The number of unique visitors per month increased from 17 to 1160 for strength of materials, 32 to 653 for fluid mechanics from 2015 to 2019, and 35 to 557 for fluid machinery from 2016 to 2019. The students' feedbacks helps the developers to improve the quality of simulation and channelize the ideas in the correct direction. It indicates that 74% of the users felt that the virtual labs closely simulated the conventional lab. 76% of the users were able to learn from the simulations without any difficulties. This method of experimental learning using simulation has been well accepted by the students. Moreover, it serves as a cost-effective, scalable, and effective means to impart practical knowledge.